Preparing for an Android developer interview can feel overwhelming, but with the right guidance you can approach it with confidence. In this video we'll walk through the most important topics you need to master, from core Android concepts to advanced Kotlin features. Whether you're a beginner or an experienced developer, this guide will help you focus your study and boost your chances of success. Let's start by understanding what interviewers are looking for and how you can structure your preparation for maximum impact. Kotlin scope functions are essential tools for writing concise and readable code. Functions like let, run with, apply, and also allow you to perform operations on objects within a certain scope, reducing boilerplate and improving clarity. Interviewers often ask about their differences and when to use each. Understanding scope functions will help you write more idiomatic Kotlin and demonstrate your grasp of modern Android development practices. ViewModel is a core component in Android's architecture, designed to manage UI-related data in a lifecycle-conscious way. It helps separate business logic from UI, making your code more maintainable and testable. Interviewers may ask about ViewModel's internal workings, its role in MVVM, and how it survives configuration changes. Mastering ViewModel concepts is crucial for building robust Android apps. Understanding the activity lifecycle is fundamental for any Android developer. The lifecycle methods, such as onCreate, onStart, onResume, onPause, onStop, and onDestroy, allow you to manage resources, handle user interactions, and ensure smooth transitions. Interviewers often test your knowledge of lifecycle callbacks and how to handle common scenarios like configuration changes or backgrounding the app. Fragments add flexibility to your UI and are managed by their own lifecycle, which is closely tied to the hosting activity. Knowing the differences between activity and fragment lifecycles and how to handle fragment transactions is a common interview topic. Be ready to discuss lifecycle callbacks like onAttach, onCreateView, and onDestroyView, and how to manage state across configuration changes. Kotlin coroutines are a modern solution for asynchronous programming in Android. They simplify background tasks, making code easier to read and maintain. Interviewers may ask about coroutine scopes, dispatchers, and exception handling. Understanding how to launch coroutines, switch contexts, and manage structured concurrency is key to writing efficient Android apps. Launch and async are two primary coroutine builders in Kotlin. Launch is used for fire and forget tasks, while async returns a result via deferred. Knowing when to use each and how they differ in terms of lifecycle and error handling is important for interview success. Be prepared to explain suspend functions and how they integrate with these coroutine builders. Efficiently handling multiple API calls is a common challenge in Android development. You may need to make parallel or sequential requests and wait for all results before updating the UI. Interviewers look for your understanding of best practices, such as using coroutines, combining results, and handling errors gracefully. Demonstrating this skill shows your ability to build responsive and robust apps. Kotlin flows are a powerful tool for handling streams of data asynchronously. They allow you to emit multiple values over time, making them ideal for observing changes in data sources. Interviewers may ask about flow operators, cold vs hot flows, and how to collect data efficiently. Mastering flows will help you handle real-time data updates in your apps. Threads and executors are foundational for managing background tasks in Android. While coroutines are now preferred, understanding traditional threading is still important. Interviewers may ask about the differences between threads, thread pools, and executors, as well as common pitfalls like memory leaks and synchronization issues. One of the most common interview questions is the difference between threads and coroutines. Threads are managed by the OS and are heavier, while coroutines are lightweight and managed by the Kotlin runtime. Understanding their performance implications and use cases will help you answer confidently and choose the right tool for the job. Android provides several launch modes for activities such as standard, singletop, singletask, and single instance. Each mode affects how activities are launched and managed in the back stack. Interviewers may ask you to explain scenarios where each mode is appropriate and how they impact user experience. Modern Android apps rely on architectural patterns like MVC, MVP, and MVVM to separate concerns and improve maintainability. Interviewers often ask about these patterns, their advantages, and how to implement them. Understanding clean architecture and domain-driven design will set you apart as a well-rounded developer. Services are used to perform long-running operations in the background, such as playing music or downloading files. Interviewers may ask about the different types of services, foreground, background, and bound, and how to manage their lifecycle. Understanding services is crucial for building responsive and efficient Android apps. Live data is a lifecycle-aware data holder that notifies observers when data changes. It's commonly used with ViewModel to update the UI reactively. Interviewers may ask about live data's benefits, how it differs from other observable patterns, and how to avoid common pitfalls like memory leaks. RecyclerView is the go-to component for displaying lists in Android. It's highly customizable and efficient, supporting large datasets and complex layouts. Interviewers may ask about the view holder pattern, adapters, and how to optimize RecyclerView performance. Mastering RecyclerView is essential for building modern Android UIs. Singleton pattern ensures that a class has only one instance and provides a global point of access to it. In Android, singletons are often used for managing shared resources like databases or network clients. Interviewers may ask you to implement a thread-safe singleton and discuss its pros and cons. Room is an abstraction layer over SQLite, making database access easier and safer. Interviewers may ask about Room's advantages, how to define entities and DAOs, and how to perform migrations. Understanding Room and SQLite is vital for building apps that require persistent local storage. Serialization and parcelable are used to transfer data between components in Android. Parcelable is preferred for performance reasons. Interviewers may ask you to implement parcelable and explain the differences with serializable. Mastering these concepts ensures smooth data transfer in your apps. Barriers and guidelines are tools in constraint layout that help you create flexible and adaptive UIs. Interviewers may ask how to use them to align views dynamically. Understanding these layout constraints will help you build responsive interfaces that look great on all devices. The navigation component simplifies in-app navigation, making it easier to manage complex flows. Interviewers may ask about navigation graphs, safe args, and deep linking. Mastering navigation ensures your users have a seamless experience moving through your app. Broadcast receivers allow your app to respond to system-wide events such as connectivity changes or incoming messages. Interviewers may ask you to implement a receiver and explain how to register it dynamically or statically. Understanding broadcast receivers is key for building interactive apps. Work Manager is the recommended solution for deferrable, guaranteed background work. It's especially useful for tasks that need to run even if the app exits or the device restarts. Interviewers may ask about constraints, chaining work, and how Work Manager compares to other background solutions. Jetpack Compose is Android's modern UI toolkit, allowing you to build declarative UIs with less code. Interviewers may ask about recomposition, state management, and the differences between Remember and Remember Savable. Mastering Compose will future-proof your Android development skills. Lazy and late initialization are two ways to defer object creation in Kotlin. Lazy is used for immutable properties, while latenate is for mutable variables. Interviewers may ask you to explain the differences and when to use each. Understanding these concepts helps you write efficient and safe Kotlin code. A solid grasp of data structures like hashmap and ArrayList is essential for Android interviews. Interviewers may ask about their internal workings, performance characteristics, and use cases. Being able to choose the right data structure for a given problem demonstrates your problem-solving skills. Kotlin offers a range of features like sealed classes, enums, open and abstract classes, objects, data classes, and interfaces. Interviewers may ask you to explain each and provide examples. Mastering these features will help you write expressive and maintainable code. Intents are used to start activities, services, or deliver broadcasts. Interviewers may ask about explicit versus implicit intents, passing data, and intent filters. Understanding intents is fundamental for building interactive and connected Android apps. Model View Intent (MVI) is an architectural pattern that emphasizes unidirectional data flow. Interviewers may ask you to compare it with MVVM or implement a simple MVI screen. Understanding MVI helps you build predictable and testable UIs. High-order functions take other functions as parameters or return them. Inline functions help reduce overhead in such cases. Interviewers may ask for examples or use cases. Understanding these concepts is key for writing efficient and expressive Kotlin code. Extension functions allow you to add new functionality to existing classes without modifying their source code. Interviewers may ask you to implement an extension function and discuss its benefits. This feature is widely used in Kotlin to write cleaner and more modular code. Dependency injection (DI) and dependency inversion principle (DIP) are key concepts in modern Android development. Interviewers may ask about frameworks like Hilt or Dagger and how DI improves testability and maintainability. Understanding these principles is essential for scalable app architecture. Memory leaks can degrade app performance and lead to crashes. Interviewers may ask how to detect and prevent leaks, such as using weak reference or avoiding static references to activities. Demonstrating your knowledge of memory management shows your attention to app quality. Networking is a core part of many Android apps. Interviewers may ask about libraries like retrofit, handling API responses, and managing errors. Understanding networking best practices ensures your apps are reliable and secure. Converting JSON strings to Kotlin data models is a common task. Interviewers may ask about parsing techniques, libraries like JSON or Moshi, and handling nested objects. Mastering JSON handling is essential for working with APIs. Understanding how to close activities properly is important for managing the app's navigation stack. Interviewers may ask about finish, finish affinity, and finish and remove task. Knowing when to use each method ensures a smooth user experience. Handlers and loopers are used to manage threads and message queues in Android. Interviewers may ask you to explain how they work together to process messages on the main or background threads. Understanding these concepts is key for advanced threading scenarios. Sync task was once a popular way to perform background operations, but it's now deprecated in favor of coroutines and work manager. Interviewers may still ask about its lifecycle and limitations. Knowing why a sync task is discouraged shows your awareness of modern best practices. Static functions are used for utility methods that don't require an instance. In Kotlin, you can use companion objects or top-level functions. Interviewers may ask you to implement a static function and explain the differences with Java's static methods. Final functions cannot be overridden in subclasses. Interviewers may ask about their use cases and how to declare them in Kotlin. Understanding final functions helps you design robust and predictable class hierarchies. Kotlin provides both companion objects and object declarations for different use cases. Interviewers may ask you to compare them and explain when to use each. Mastering these concepts helps you write idiomatic Kotlin code. ViewPager allows users to swipe between pages of content. Interviewers may ask about its setup, adapters, and how to handle fragments efficiently. Understanding ViewPager is important for building interactive and user-friendly UIs. Every Android project specifies compile SDK, target SDK, and min SDK versions. Interviewers may ask about their differences and how they affect app compatibility. Understanding SDK versions ensures your app runs smoothly across devices. Optimizing app startup time is crucial for user experience. Interviewers may ask about techniques like lazy loading, reducing dependencies, and profiling tools. Demonstrating your ability to improve startup time shows your attention to performance. Dependencies and plugins are both used in Android projects, but they serve different purposes. Interviewers may ask you to explain the distinction and provide examples. Understanding this difference is important for managing your project's build process. Kotlin's delegation pattern allows you to delegate property access to another object. Interviewers may ask about standard delegates like lazy and observable. Mastering delegates helps you write more modular and reusable code. Infix functions allow you to call functions without using parentheses or dots, making your code more readable. Interviewers may ask you to implement an infix function and explain its benefits. Understanding infix notation is a nice touch for writing expressive Kotlin code. Creating a release sign build is an essential step before publishing your app. Interviewers may ask about the signing process, key stores, and best practices for securing your keys. Understanding this process ensures your app is ready for distribution. Push notifications keep users engaged by delivering timely updates. Interviewers may ask about implementing push notifications using Firebase Cloud Messaging, handling notification channels, and managing background delivery. Mastering push notifications is key for interactive apps. Publishing your app to the Google Play Store involves several steps, including preparing assets, signing the APK, and completing the listing. Interviewers may ask you to outline the process and discuss common pitfalls. Understanding the publishing workflow is essential for any Android developer. Permissions are required for accessing sensitive data or device features. Interviewers may ask about requesting permissions at runtime, handling denial, and best practices for user privacy. Mastering permission management is crucial for building secure apps. Glide is a popular image loading library for Android. Interviewers may ask about its internal workings, caching strategies, and how to optimize image loading. Understanding Glide helps you build smooth and visually appealing apps. String Builder is used for efficient string manipulation in Java and Kotlin. Interviewers may ask about its advantages over string concatenation and common use cases. Mastering String Builder helps you write performant code when working with large or dynamic strings. Practicing with interview questions and cheat sheets is a great way to reinforce your knowledge. Interviewers may ask you to solve coding problems or explain concepts from memory. Reviewing common questions helps you identify weak areas and build confidence. A strong foundation in Kotlin is essential for Android development. Interviewers may ask about advanced topics, strong versus weak references, and best practices. Mastering Kotlin fundamentals will help you tackle any coding challenge with confidence. Hearing about real interview experiences from companies like Zomato, Mercury, PhonePe, and Swiggy can provide valuable insights. These stories highlight the types of questions asked, the interview process, and tips for success. Learning from others' journeys can help you prepare more effectively. There are many excellent articles and guides available on Medium and other platforms. Topics like certificate pinning, advanced coroutines, and clean architecture are frequently covered. Exploring these resources will deepen your understanding and keep you up to date with industry trends. To become a senior Android developer, you need to master advanced topics like shared flows, clean architecture, and scalable solutions. Interviewers may look for your ability to design complex systems and mentor others. Focusing on these skills will help you advance your career. Implementing clean architecture in mobile development can be challenging. Interviewers may ask about common struggles such as scaling, testing, and maintaining separation of concerns. Being able to discuss these challenges shows your depth of experience. The world of Android development is always evolving. Staying curious, experimenting with new technologies, and learning from the community will keep your skills sharp. Remember, there's always something new to discover, and every interview is a chance to grow. We've covered a comprehensive list of Android interview topics from core concepts to advanced patterns. Review each area, practice coding, and don't hesitate to explore additional resources. With focused preparation, you'll be ready to tackle any Android interview and take the next step in your career.